sustainable innovation. And I'd like to bring in our colleague, Ed Cohen, to tell us about a new strategy that mixes technology with the natural world. Ed?
Hi, this is Ed Cohen from Mount Laurel. And I'm just here actually to introduce our main speaker, Dr. A.J. Both, an extension specialist with Rutgers University. He has a Ph.D. from Cornell University in Department of Agriculture and Biological Engineering, and he will be talking about agrivoltaics. Dr.
Good afternoon or good evening, everybody. I hope you can hear me. Let me start sharing my screen. I hope you can see this. I'll start.
Looks good.
As Ed said, my name is A.J. Both. I'm a faculty member in the Department of Environmental Sciences at Rutgers University in the School of Environmental and Biological Sciences. And I'm also a member of a relatively new program called the Rutgers Agrivoltaics program. And that program consists of about 12 staff and faculty that is tasked with investigating the potential benefits of agrivoltaics for New Jersey conditions. And so I'd like to share with you what we have been working on over the last year and a half or so, and give you an idea of where we think this technology may go in the near future. So first, I'd like to share with you what we think agrivoltaics is not. And that doesn't mean that what I'm just going to show you here is a bad idea. It only means that we think, our group thinks, that this is not something that falls under the term agrivoltaics. So the first thing that we list here is a solar farm. You're probably familiar with them. If you drive around New Jersey, you see large pieces of property converted into a solar farm, panels mounted close to the ground. And that typically means that there is no more agriculture possible on that field. And since these systems are going to be in place for at least 20 years or so, that means that that land is no longer available for agriculture. We also think that agrivoltaics is not a solar farm with a few small animals grazing, for example, sheep or chicken. And finally, we don't think agrivoltaics is a solar farm combined with apiaries or pollinator habitats. Again, these are all interesting ideas, and we certainly think they have a place, but that is not the focus of our group. So we focus on agrivoltaics, as I'm going to define to you shortly, and it's also called dual-use solar. So the main purpose of this technology is that the land will remain in agricultural use, but it will also be used for some solar energy generation. We feel strongly that agriculture should remain the first activity and the main activity on the property, but as I said, we will be adding some solar energy generation. The structures will follow, will allow for multiple types of agriculture. So whether that is animal grazing or hay or specialty crops or regular agricultural crops, all of that should be possible using this agrivoltaics approach. And the goal is, at least the goal that we have in mind, is that combining agriculture on that property with agrivoltaics, with photovoltaics, will provide a better return, a lower risk approach to agriculture compared to the traditional sole agriculture activity. And of course, there are added benefits. It keeps the land available for agriculture, which is an important goal that we have in New Jersey. Think about the preserved farmland that we have. And it also contributes to New Jersey's renewable energy goals. As you know, those are fairly aggressive. By 2050, we should at least have all of our electricity come from renewable energy sources. And 2050 is not that far away. So this is a major challenge that we have set for ourselves. So again, we don't think solar farms, as you see an example here, are agrivoltaics, because as I said, it takes most of the land out of agriculture production. So it's no longer about farming, it's only about electricity generation. And again, there's nothing wrong with that. We think, if you think about agrivoltaics, that's not the direction we need to go into. Again, we do not think that agrivoltaics is combining photovoltaics with sheep grazing. it is an interesting approach, and it's certainly done in different locations around the state. But if you talk about agrivoltaics and follow the definition that I just outlined, this is not an activity we feel falls under agrivoltaics. And finally, as I mentioned before, we don't think creating pollinator habitats or apiaries around solar farms is a good fit with the terminology agrivoltaics. So what is agrivoltaics? I'll give you some examples. So here you see an example of grazing cattle. So we want to minimize the impact of the panels on farming by perhaps elevating them and increasing the distance between the rows of panels. And as you can see here, there's relatively little impact. Clearly, you're going to get some shading on the land below, so you will very likely get some reduction in this case, growing grass. But on the other hand, you're also generating electricity. And again, if these two activities combined provide a better income for the farmer, then we think we have a winning situation. Another idea that we discovered in Germany are these vertically mounted panels. And you may think that this is not a very good use of solar panels, but these panels are oriented in rows that are going north to south. And so you're collecting solar panels, solar energy when the sun is coming up in the east and during the morning hours, and when the sun is going down during the afternoon hours on the west side. And because these panels are bifacial, you generate electricity early in the day and later in the day. And that means that you can offset your electricity generation from the typical solar situation where you generate most of your electricity during the middle of the day. So this will allow some spreading of the production throughout the day hours and not produce as all the other systems during the middle of the day. These vertical panels can also be installed in multiple heights. Here you see a system with double rows mounted one on top of the other. And the post spacing is designed so that large equipment like this mower can still move easily between the rows of panels. So the impact again on the agricultural activity is relatively minor. Colleagues at the University of Massachusetts have also done some research and published some of their results about agrivoltaics. Here you see one of their installations using so-called fixed tilt panels that are oriented at a fixed angle facing south, elevated above multiple rows of vegetable crops. There's a very interesting approach to this idea in Colorado, Jack's Solar Garden. And in this case, they have installed so-called single axis trackers. So these panels are rotating around a horizontal axis, following the position of the sun throughout the day. So they are facing east in the morning. They are more or less positioned horizontal during the middle of the day. And then at the end of the day, they're facing west. And so there's a system that automatically rotates these panels as the sun moves to the sky. And this particular installation is called the community solar system because not only is the electricity used on the farm, but because it's a fairly large installation, the excess electricity is used by the community, by individual homeowners that are connected to this system and are reaping the benefit of this particular enterprise. In France, they use similar systems that are elevated much higher. Here again, you see single axis trackers, so these track throughout the day again to try to capture as much sunlight as possible, but they are elevated high enough that large equipment can pass underneath, again minimizing the impact of the system on the agricultural activities underneath. And in Germany, they use similar systems that are also raised quite high. In fact, these are raised so high that a regular combine harvester is able to move underneath these systems and conduct regular field operation, again, with minimal impact on the farming activities from the solar panels. As I said, we are doing research in New Jersey, and we have received an appropriation from the state of New Jersey with the intent of installing a variety of agrivoltaic systems at 4 farms that are operated by the New Jersey Ag Experiment Station. You see the locations indicated by stars across the state. In New Brunswick, at our animal farm, we want to install one of these vertical installations, panel installations that I showed you earlier. And then at 3 more sites at Bridgeton and at the RARAC, Rutgers Agricultural Research and Extension Center in RARAC, we want to install a relatively large system, and then 2 smaller systems, one at our Snyder farm and one out at a farm we called Cream Ridge, indicated in this slide. So with the funding from the state, we hope to complete these 4 installations in the next year or so. And after that, we intend to do agricultural field trials, both for animal production as well as field crop production and vegetable production, to get solid data that we then hope can be used by regulators such as the New Jersey Board of Public Utilities, who has been tasked by the state to implement a dual-use solar pilot program. And they need information to set the standards and the guidelines for that pilot program. And we hope to provide them with a lot of our research results in order to implement the particular guidelines they need for that program. We're doing some preliminary research at Rutgers as well, both at our animal farm and at the in South Jersey at our Rutgers Agricultural Research and Extension Center. We have installed some simple designs using plywood panels, because at the moment we didn't have the funding to install real solar panels, but these plywood panels are simulating what the impact might be of various installations on things like the local weather, including temperature, humidity, soil radiation data, as well as soil conditions such as soil temperature and soil humidity. So we're collecting all this data that will inform us what we think the impact will be once we have these real installations installed at our various research sites. And finally, we're also looking at the more engineering side of things. We have developed several models that are looking at shadow patterns, because obviously these panel systems will create shadow bands. And depending on the design of these systems, those shadow bands will move more or less throughout the day, creating more heavier shadow bands or hopefully less heavier shadow bands. And by simulating the light conditions around and underneath the various panel designs, we can make assessments about the impact that might have on the various crops or animal systems we'd like to trial in and around these systems. So with all of that, we hope to get a good set of data that again we can help our regulators with at the state, who are going to implement a pilot program that is trying to look at the same idea of agrivoltaics, but now installed at real farms. And hopefully that will then once and for all demonstrate that this idea has merit in New Jersey and warrants further expansion across the state. So with that, I'll close, and I'm happy to answer any questions. And you have my email address on this slide and the first slide if you want to contact me later offline. Thank you very much for the opportunity to talk to you.
Dr. Both, thank you so very much. Thank you for disabusing us of the incorrect interpretation we had of what agrivoltaics must be. This is fascinating, and it actually is a whole new area. One of the questions that we did get was the question that you have, and you are trying to address by looking at the shadow patterns. Is there evidence at this point as to what the impact might be of this decrease in sunlight, or is that something that is wholly open to investigation?
There is some information already available. For example, if you have a fixed tilt system that is typically facing south and is relatively close to the ground, so a typical solar farm installation, you will have an area underneath the panels that is heavily shaded throughout most of the day. But if you increase the elevation of the panels and you also make them track the sunlight, now you create shadow patterns that are much less pronounced and also move throughout the day, and therefore have a much smaller impact on the agriculture that you want to do around and underneath the systems. So yes, we have some quantitative data. We want to verify that obviously when we have our real systems installed.
But I suppose that would also open up another horizon for the agricultural community in terms of trying to match the crops that might be grown under specific conditions of sunlight.
Exactly, and that's part of the research we want to do. We want to experiment with a variety of crops. Some of them that we know can deal with shade, some of them that we know are perhaps benefiting from less intense solar radiation during the middle of the day and during the middle of the summer season. All of that is going to be important for us to understand how the farmer can benefit from these systems once they are installed.
Well, this is very exciting. Thank you so very much for your presentation and for educating us about this whole new horizon. Thank you.
You're very welcome. Thank you.
We appreciate it. And if there are more questions, of course, we can forward them to Dr. Both later as well. But don't hesitate to add them in the chat. Thank you.